it already seems that we are running through a scientific fiction movie with the type of topics that we have already discussed. It is a wonderful, I would rather congratulate Dr. Vijay Agarwal and the team of organizers to looking forward to one of the very important topics like digital transformation in healthcare nowadays. I'm a neurosurgeon by profession and a great proponent of use of technology in healthcare. Earlier, it used to be when we were studying that man behind the machine was important. But now is the time when machine behind the man, it has become important. Now, as a clinician, our results are improving because we are using machines, we are using better technology, we are using artificial intelligence in our diagnosis, in our prediction of diagnosis, management protocols, and predicting prognosis in patients. Just based on this, our next topic for discussion is role of artificial intelligence and the Internet of Things, and what is the future for them. Since many of us would not be really sure about how it is being done nowadays, I'll just give a brief about that. Artificial intelligence is not just one technology, but it is a collection of multiple of them. It simplifies the lives of doctors, patients, and hospital administrators by performing tasks that are typically done by human beings, but in lesser time, in much more accurate fashion, and in a fraction of the cost. And the key categories nowadays of its applications, it involves diagnosis and treatment recommendations and administrative activities in addition. For a brief about Internet of Things, it is a system of interrelated computing devices, mechanical or digital machines. It could be objects or people, but they could be provided a unique ID and ability to transfer data over a network without requiring human to human or human to computer interaction. We go on to the next talk, which is by Mr. Mor. He's a sales manager at CAHOTECH Science. And without going into much detail, it's more about what we do in Internet of Things and what our ecosystem is. But whenever we are using all these things, making our homes smart homes, or we're using devices for all these things, there's always an issue of security and privacy. And now this is going to be an important talk because it tells us about how to build trust in wearables and sensors, particularly in the sense that whatever data that is being collected is actually a good data for analysis and taking action on. Over to you, Mr. Mor.
Thank you, Dr. Naveen. Thank you very much, the CAHO management led by Dr. Agarwal. I would like to thank you for inviting me. CAHOTECH Sense is an Israeli-based company based in Caesarea, which was a city that was built 2,000 years ago as part of the Roman Empire. And 2,000 years later has become a Silicon Valley for medical devices company. That's our home there. I will talk a little bit about the CAHOTECH Sense medical watch. CAHOTECH Sense medical watch is the only medically approved medical device for continuously measuring AFib in an accuracy which is around 99%. And I will elaborate a little bit more on the technology. Basically, wearable. The question is how to build trust in wearable devices. So I think the market has already spoken. I think if we talk about, I don't know if you can see the watch, medical watch, the one that I'm wearing, is the most highly used device for mainly for well-being, but also it's starting to be used in medical environment as a watch, as a bracelet, as a ring, or any other type of wearable. And the reason is that the compliance is much higher than any other type of solution. Also, it allows the patient to keep independent living at home, on the streets, anywhere, basically. unlike other solutions which require either the patient to be lying down or putting a patch that is can be used for a day, 2 days, 3 days, or halters on this type, from all types. So I will talk a little bit about the issue of accuracy, and I will ask a different question. And can we trust wearable device? The answer is yes, but it depends for which use. If you want to use it for medical environment and to be able to be used by hospitals or for home care providers or by doctors, it needs to be first medically approved. And when we talk medically approved, initially it would be CE, MDR, or FDA. And basically that give you some kind of assurance that medical trial will done with the right procedure. However, it does not give you all the information you need about the accuracy of the device. And if we talk about well-being, we talk about accuracy. For example, if I talk about AFib, we talk about accuracy of between 15 to 30%, which means if you use a well-being device for medical purpose or to for doctors to help them diagnose AFib or other type of arrhythmias, it will overflow the doctors and will not be able to give them an efficient usage of the device. If we talk about a medically registered device, it should be around 99 to 98% accuracy and specificity. And that will allow the doctors to get accurate data from the device. So if we talk about the watch, as I show here, it has a set of sensors on the bottom of the watch. We talk about the PPG, which is a plethysmograph, which is basically a diode, which is measuring the reflection of light or the light which is going through the peripheral blood vessel. So it can measure the change of the volume of blood in the peripheral blood vessel. But this sensor by itself will not give you an accurate result. And when you don't get an accurate result, basically all the data that is being used is interfering with the accurate diagnosis of AFib. I'm taking AFib as an example because I think one of the other panel members mentioned stroke patients who are lying in bed and can be monitored. One of the reasons that there is a focus on AFib because AFib is one of the major leading factors for ischemic strokes, which is the most common strokes in the world. And I think the risk at AFib is that 15 to 46% of patients are asymptomatic. So the usage of this device is not only recommended, but I think it could be mandatory for detecting ahead of time any deterioration with the patient condition. And I think that one of the principles of today value-based healthcare is to try and do prevention instead of curing, which is definitely much better for the quality of life of the patient, because I don't want to be a patient after stroke. I want to be able to prevent it. So if we talk about the AFib, when people are asymptomatic, they are not aware of the risk. And if we talk about stroke patient, between 21 to 59% were diagnosed after the stroke that they were having AFib, which was too late. So one of the ways for us to increase the accuracy, as I mentioned before, accuracy is the name of the game. If you don't have accuracy of 98 or 99%, you better not use the device. So if you use PPG sensor only, you will not be accurate enough for medical usage. So what we do, we use a composition of sensor, which include, of course, the PPG, mechanical sensors, and the combination of this sensor allows to get from the heart rate monitoring a very accurate signal, which eliminate, small signals of the fingers, which are exist in any patient. So today, what does a well-being device basically use averaging of the results, and therefore the accuracy is much lower, as I specified before. So we use this sensor in combination with the one lead electrode, which is the bottom electrode. We use the artifact sensor to analyze and eliminate the noise from the signal. So we monitor continuously the signal with high accuracy, and then when there is a AFib detection, the patient get an alert and immediately instructed to do an ECG test. So even if you have some symptoms like syncope or like palpitations, you can immediately start a real-time test. The ECG can be shared in a report with the physician, or can be kept on the device and later shared by the physician, but it allows to give immediate and real-time information to the physician. As part of our, as some other of the panel speakers said, we talk about a complete solution because a monitoring device is not enough. So we can combine it with AI, which is based on a cloud, and we talk about secured cloud. So this brings the information in a secured environment, and the only information is accessed by the patient itself, so nobody else could access it. It's GDPR and HIPAA compliant. And the only one who can watch the data is the nurse or the physician in hospital, and then it could be, of course, a closed local cloud. If we talk about clinics and home care, it will be watched only by the designated doctor, by the patient. So in terms of security, the system is highly secure, and it can be watched only by designated doctor, by in home care, or by the family member. So I think one of the advantages, and this is why the answer is yes, you can trust a wearable device, but you first, for medical usage, you need to look at the accuracy, at the medically regulatory certificate of the device, and also you should try it. You should try it on your patient before implement it, in order to see firsthand the accuracy of the device. Of course, what you require from the device is to be high compliance and to include as much as possible vital signs monitoring sensor, and to be continuous. For example, if you want to detect sleep apnea, the watch can be on your hand, and you can detect sleep apnea while you sleep. There will be alerts coming to the system. In case you have pause, it will be alerting you also on the watch itself. Yeah. Just to mention, we are now launching it in India. We launched it in other 26 countries, and it's being tested in many medical institutions in the US, in Israel, and we look forward to be in touch with you if you have any questions, or if you want to see the article about accuracy of the device and the set type of sensors we use.
Thank you, Mr. Mor. It was quite informative, and I'm really sure that it is going to save many lives of stroke patients in particular by decreasing the door-to-needle times in the patients if they're diagnosed early. Thanks a lot.
Thank you very much.